We have more people coming in. We're going to just wait one more minute. Thank you for your patience, and hopefully it'll be well worth it. Okay, let's get started. Again, I want to thank everyone for attending the webinar on how all engineers and designers can perform generative design, put on by Paramatters. I'm Ed Chapman, heading up sales and marketing. I'm on with Dr. Michael Bagomly, our CTO, and we're going to take you through the current state of generative design and where it's going and why you should be doing generative design today. Okay, let's go to the next slide. So effectively, a little bit about Paramatters. We are the leading generative design advanced manufacturing software company. In other words, we are the only company that was put together to develop a world-class generative design solution. And we really have developed what I would call a killer app, and really the missing piece for enabling adoption of generative design. We're going to present today, the benefits that organizations are seeing from generative design. But what's really amazing is that there's still not enough adoption. And I think, the root cause of that has been the fact that there really hasn't been a solution for generative design until today. Next slide. A little bit about our team. We have a bunch of smart people on the team, a lot of PhDs and people that come from the industry. So we have people from Altair, Dassault, Ansys, Onshape, MSC, and more that really came to Paramatters to focus on generative design and building the best tool. We have a number of different publications and citations. We are considered the thought leaders in generative design. Next slide. We have a number of great customers saying great things about us in terms of what we've been able to do and accomplish with generative design. And we're hopefully going to show you that today. Next slide. So you really can't ignore generative design. I've read a lot of articles and been to a lot of presentations and where organizations are saying that, well, it's coming, this is the future, but it really is today. If you look at some of the analyst reports, they're saying that generative design is going to have a compound annual growth rate of 24% over the next 10 years. That's amazing. Reaching a total of 44 billion plus by 2030 and 16 million users. So in other words, you can't ignore this any longer. This is something that you have to incorporate into your design and product development process. The results are too amazing between cost reduction, weight reduction, development time reduction, better yield on manufacturing. And what's really interesting, so initially organizations were talking about topology optimization, which added certain value, but there really wasn't a lot of adoption with that. Generative design is different because it actually creates iterations and variations of designs that can actually be manufactured. And that's important, that it takes that design for manufacturability element into consideration. And they're actually designs that you can produce. Next slide. So if you look at it in terms of what are engineers and designers able to do with generative design, they can put in their functional requirements, physical size, material strength, the weight, the heat, the load and boundary conditions, the dynamics, et cetera, into consideration, as well as a manufacturing process. And they can also consider other constraints, such as cost, availability of material, even the supply chain constraints. And that's really important given today's environment. So the fact that you're able to take all that into consideration and leveraging the technology to help you think through that So in other words, this is really a very symbiotic relationship with the engineer designer and the tool. The tool can't function on its own, really needs the input from the designer to be able to make it work. But really the end result is that you're able to test new shapes and geometries very quickly, do different types of parameter studies, easily come out with detailed designs for engineering and manufacturing. And not just for new designs, but we're seeing a lot of applications where organizations can do product improvement, take existing designs and figure, okay, can I lightweight this? Can I use a different material type to manufacture? Can I manufacture in a different way to reduce cost? So it's not just on new designs. Next slide. So some of the value that's being derived from generative design, being able to use less material, less energy, in additive manufacturing, other manufacturing processes. You can do a variety of different design studies and varying different parameters, including materials, which is what we're going to show you today is one of the parameters that we're going to modify. And basically, transforming the productivity of every engineer in the organization. Okay, some examples where Airbus used generative design to reduce material and cut weight by 45%. GM took a seat bracket, 8-part assembly, and cut that into one part. And we'll go into a little bit more detail in the next slide. Here's an example. So again, a seatbelt bracket, which is made up of 8 parts from 8 different suppliers. GM was able to use generative design to turn into one part, which could come from one supplier. Made the part 40% lighter, 20% stronger than the original. I mean, those are really transformative results. Black & Decker took an overhead tool that was heavy, reduced the weight by 20%. Took the manufacturing time from a month to down to 20 hours. GE took a bracket and reduced the weight by 75% and maintained structural integrity. So these are the type of transformative results that can be achieved with generative design. And here's some other examples of parts and components that have been optimized with generative design, some of the results. Next slide. So it's really a must-have solution. It's one of those things that you just can't ignore it anymore. And it's not just us saying this, it's the industry experts, ABI, McKinsey, where it's going to allow you to improve sustainability and profits, explore different designs and materials in a very unique and powerful way. Streamline the design through manufacturing process. So in other words, because you're taking manufacturability into consideration, as well as the loads and boundary conditions and the structural integrity, this truly enables engineers to think about designs in a different way where they can consider manufacturability and structural integrity together. And basically you're seeing as much as 80% productivity gains in product development. Next slide. So why hasn't this been adopted in a wider way? And mostly it's because the tools that have been out there have been more centered on traditional simulation, traditional topology optimization, because the providers of those tools, that's their core technology. So it was really hard for them to think about generative design in a unique way. They had to live off and build off their existing technology base, which really wasn't built for generative design. So Parameters and CogniCAD is the first solution out there that was designed for generative design, incorporating AI and machine learning algorithms to enable the geometry optimization and combined with the structural integrity and manufacturability. It's intelligent, it automates a lot of the steps, so it's very, very easy to use, very, very intuitive. It integrates design and manufacturing, and it's CAD and CA agnostics. In other words, you don't have to change your environment. Okay, you can work with the tools that you have today, and this is an add-on to be able to give you that generative design option. Okay, next slide. So what's in it? Basically, we have the structural, mechanical, static and vibration simulation that goes along with thermal to take that into consideration as you're creating your design. So this happens, in parallel with developing the geometry. You could basically take any geometry from the CAD model and apply generative design to it. So again, it's CAD agnostic. It can be an existing part that you can now run through generative design. It can be a lump model that you can say, okay, here's my loads and boundary conditions. Here's my design objectives. Go figure this out for me. So it can work in a variety of different ways. Okay, and again, it's designed to be able to take advantage of advanced manufacturing and enables advanced manufacturing in terms of lattice and structure support. Next slide. Going a little bit more detail, and you see some examples of how it works on the right. Basically, as I said, AI machine learning algorithms, which incorporates structural vibration and heat conduction. It's a pure mathematical approach, and Michael will talk a little bit about that when he shows you the example. It's very lightweight. So in other words, it provides this type of capability in simulation very, very quickly. We've done generative designs live during a demonstration in 30 minutes or less. So that's another unique element to this. It's not a heavy duty application. It was built so it could be fast, lightweight, and smart. Okay, next step. Next slide. Going a little bit more detail in terms of what it does with the structural piece, but then it can also output for manufacturing, whether it's a step file, STL for additive manufacturing, and really if you are and have additive manufacturing, it's really designed to be optimized for that. Next slide. The other thing is that we take into consideration multiple materials, which is unique. No one else is doing that. So this way, if now you're incorporating designs and you really want to get creative, you can apply different material types into your model, and we're able to solve and design for that. So again, very, very unique, very, very powerful. Next slide. And then, as I mentioned, we have the additive manufacturing where, we can produce the models for additive manufacturing, put out to an STL or PLY file, build the lattice structures and support structures automatically. And it's really designed to be able to optimize that as well. So you actually reduce the material requirements of your additive manufacturing solution. But we also support other manufacturing operations as well, not just additive. Next slide. Okay, just getting into a couple examples, and then I'm going to turn it over to Michael to show you exactly how it works. This is a redesign of our bracket for ECOS, where they wanted to lightweight a mounting bracket and really think about fatigue and vibration loading as part of the design consideration and optimizing for that. They were able to reduce weight by 35%, stress reduction 20% reduction, and natural frequency mode increase. Actually, they reduced that as well. And then that it was actually the part was produced by Renishaw. Next slide. Example where we took a suspension system, cut the number of components in the suspension system, reduced the weight, the design cycle by over a week, and produced this for investment casting. Next slide. Here's an example from Airbus where they're doing a hydraulic manifold. They want to do part consolidation here as well as lightweighting. Obviously, structural integrity was important, so they had to maintain that, and they're actually able to lower costs of the design as well. Next slide. Okay, at this point, I'm going to transition over to Michael, and he's going to take you through a real example of one of our customers and how we transformed one of their machines. Michael?
Yeah, thanks, Ed. Good morning, everybody. So I would like to show the very, I would say, unique process taken from machinery industry with our customer TCM, Italian company, machinery company. And just briefly to explain the idea of what happened here, we got an assembly of the machinery, and actually we immediately identified there are many candidates here for generative design. And when we talk about generative design, as Ed mentioned, it's not only lightweighting, it's also part consolidation when we combine generative design with additive. So we identified, let me quickly jump back here. We identify, for example, these two components, and it's clear that instead of having two parts, we consolidate them. So basically in CAD, it's a very simple operation. We can create this, what we call design space. Now, what is also important in generative design, each part or component that we design is a part of the assembly. So we need to keep interfaces to be untouched, what we call non-design. So basically, user, what he has to do, he has to take his CAD and import it as a step file into our process. Very simple. Now, after that, you go to CogniCAD. This is a CogniCAD interface, our software, and you just import this step file assembly into our platform. And then the process is very intuitive and easy to use. Let me just stop it here in the show. So there are very intuitive steps. First is to define material, what material type we would like to use with basic parameters. And then classification of the design space, some non-design features, basically what we want to keep untouched by the process. And we apply various loading conditions. As Edward mentioned, this can be static, free vibration modes, or other load cases, thermal load cases. When we talk about loading conditions, these can be forces, moments, pressure, acceleration loads, and so on. And the design goal, which we would like to define in this case, is to say, okay, if this part is made of aluminum, we want to keep stresses below yield stress, or if you want to have it's a fatigue application, we would like to have some safety factor. So for instance, we bought safety factor of 2 here, and we define our requirements, and software provides the final design as you see here. It is smooth, it is watertight modeled, which does not require any manual post processing, any sculpturing or reconstruction of geometry, which is very tedious. Software provides right-to-weight design backed by software provides design which is backed by finite element analysis, of course, and we can see our design, including the FEA, which includes deformations and stresses. We typically consider von Mises stresses. So actually here, if we change material, for instance, from aluminum to steel, of course, design should be different because material is stiffer and lighter. So you will see now, so this is a design for steel. You see it's have less volume. We can allow here higher stresses. And of course, design looks differently. So you see generative design is really intelligent way of design, taking physics into consideration. So here we considered for the same part plastic, pretty stiff plastic produced by DSM. And we see again, part have higher volume, but this part have lower stresses, of course, and we can allow lower stresses. So we really can vary different materials here. Now, for those of you who are less familiar with finite element settings, saying not to apply loads, for industrial designers, we have developed additional procedure when if you don't really know what's the loading condition or less familiar with the finite element setup, and you would like to have still organic and nice designs. So this is a functionality where a user can just select the application field, the boundary condition, and the volume fraction of material and run the study. There is no need to define any loading. And this is a result for this case. You see, part is pretty much organic, nice, and makes a lot of engineering sense as well. So even without knowing what the loading condition, you're able to get very high quality designs. And so once we have generated our designs, we can bring them back into the assembly, and you can see how model fits exactly the design space which we initially defined. It preserves all the interfaces and non-design regions perfectly, and it's really ready for manufacturing. So if we look at the whole component, basically in this project that we did, we designed many parts in the same way. And what is nice here that 7 parts were generated within less than 2 days by a single engineer. This is shows how effective is our flow when there is no need to do any manual post-processing, any manual manipulation. Software provides final design as is, and in average we could achieve lightweighting between 45 to 70% in each part. So, and just to show that it's very important that we don't just generate nice shape. These shapes are models, designs are fully manufacturable. We work closely with various manufacturing companies and make sure that all designs we generate are fully manufacturable. And within CogniCAD, the design can be taken to manufacturing using also our support generation capabilities. And this part is printed as post machined, and you see it's all fully manufacturable. So from design to manufacturing, you can get nearly using one-click solution. And yeah, Ed, I will take it over you.
Thanks, Michael. That was great presentation, and it's amazing that you're able to go right from design to manufacturing. And I've heard the Nexa 3D printer is the best on the market right now, so that's great. So I want to get into some Q&A, but first, want to about how you can get started in getting value from generative design. It's very simple. As Michael said, this is a push button solution. A couple of different ways you can get started with Paramatters. One, if there's a design that you want us to optimize, we're willing to do that for free. You can conduct a 30-day trial of your own. Software is very usable. We just require a little bit of training. And then you can always buy a license. Extremely affordable, and it can fit within any budget. So certainly to learn more, just contact sales@paramatters.com. All right, so Michael, I'll get some questions for you.
Yes, please.
Does this work with any CAD solution?
Yes, so typically each CAD system has his own format, but there are some CAD formats, file formats, which kind of agnostic to any CAD system, like STEP or STP format. So yes, any CAD system today can export STEP file, and CogniCAD can read STEP files, and we export STEP files of the final optimal design. So basically, the short answer is yes, we aligned with any CAD systems.
Okay, next question. How do you know that you have an optimal design from Paramatters?
Well, how do we know? Well, first of all, our generative design process is fully backed by physics, what I say. Physics meaning we take physical phenomena into account. Finite element analysis is a part of the generative design process. And purely purely mathematical approach, finding the optimal material distribution. And hence we have nearly mathematical proof that the designs that we generate are optimal.
Okay, great. Some more questions coming in. Do the models need to be run in an FEA tool?
Well, FEA is a part of generative design process, as I mentioned, and we have developed our proprietary finite element solvers because we need to work on very high resolution for generative design. Our finite element solution was compared versus market standards like ANSYS, OptiStruct, and we get very good agreement between market standards. We use typical finite element formulation, but we really innovated in the field of finite element solvers. We are able to solve huge problems like millions, tens of millions of elements.
Okay. Does Paramatters work with all materials?
Yes. So right now, as long as material is isotropic or close to isotropy, yes, you can use CogniCAD with any isotropic material, and in near future we will also allow use of anisotropic materials.
Okay. So there's a question: is it CogniCAD or Paramatters? Just for clarity, the company's Paramatters and product is CogniCAD, but a lot of times we refer to it as Paramatters. So just for clarity on that. And another question: does it still run on Amazon servers?
Yes. So platform, we started initially as cloud solution, and the reason why it is a cloud solution is that running, as I mentioned before, in order to generate high quality designs, it's a combination of many new technologies, and one of them, for instance, high resolution. High resolution means very effective solvers, but for this you need the computational resources, and we decided to democratize generative design, not keep it only for big organizations who can afford expensive hardware. So the offering as a service on the cloud, you can generate results which were unimaginable before. And yes, the AWS, Amazon platform is very robust, and this is what we use today. In addition to the cloud version that I mentioned, we also offer a Windows local installation. So for those who have some security constraints and cannot upload their models on the cloud. Of course, we provide the full confidentiality of all users' models on the cloud, but for those who cannot work with the cloud, we also offer Windows local version.
Michael, there's a number of different questions regarding the FEA solver that we're using, or the structural solver that is driving the engine. Maybe just talk a little bit to that for people.
Well, I didn't see the question, so I'm not sure about the.
Well, there's a number of different questions, and maybe just go into a little bit more detail about the algorithms and how it's designed for.
Well, it's a proprietary development, so I'm a little bit suspicious to talk. We don't talk about algorithms themselves. I just can say that we use very effective iterative solvers which scale effectively, and we take advantage of repeatable solution of finite element system of equation. And but more than that, I cannot say at this moment.
Okay. Great. And then in terms of getting started and training, a couple questions have come in around that.
Yeah, so when we designed, from our rich experience working with traditional CAE CAD tools, the learning curve is very steep. It takes a lot of time to start working. And then when we designed our UI in CogniCAD and in Paramatters, we intentionally wanted to target flow which will be very intuitive and easy to use. And what we experienced that many users without any training can successfully run the design flow within parameters. Of course, we make online guidance and training, as well as in any time zone. We have people in European and also in American time zones. Of course, we provide some video tutorials as well. But generally speaking, you just get your hands on the software. It's very intuitive and easy to use.
Okay, thank you, Michael. We're starting to run over. There's been some pricing questions. You know, I'm going to be following up with everyone. I can go into more detail on pricing on a one-on-one basis. But again, it's an extremely affordable solution, so anybody could use it. Well, I want to thank everyone for participating today. Hopefully it was educational and enlightening. You saw some value. Michael, thank you for your walking us through the Q&A session and the demonstration. And again, we'll be doing more of these, so look for future emails on webinar invites, and certainly contact us, you know, for if you want to buy a license, or if you want to do a trial, or if you want us to optimize a part for you. Thank you, everyone, and enjoy the rest of your day.
Thank you.